Welcome back to our Essential Vector series sponsored by Avemco Insurance. In this edition, we will look at some essential information regarding low-level wind shear. My name is Gene Benson. First, an important note. Low-level wind shear is a very complex topic. A brief video such as this cannot address all aspects of the meteorology involved, detection strategies, nor mitigation approaches. To learn more about this important subject, please refer to FAA and National Weather Service publications. So to begin, which is correct? Wind shear as one word or two words? We see it both ways, and it appears that either one is acceptable. Even the FAA and NTSB seem to use the two interchangeably. When doing a search of the probable causes of airplane accidents on the NTSB database, using it as one word will yield results, and then searching again using two words will also yield results. So in the spirit of being equitable, you will see it used both ways in this presentation. Wind shear is a change in the wind speed and/or direction over a short distance. It can occur either horizontally or vertically and is most often associated with strong temperature inversions or density gradients. Wind shear can occur at high or low altitude, but we will limit our discussion to low altitude wind shear. I want to stress that we do not need a strong wind shear to cause problems. We might read about wind shear events in which a large airliner has crashed short of the runway on approach due to wind shear. But far more common is a relatively weak wind shear resulting in a general aviation airplane incurring a runway excursion by landing short, going off the departure end, or off the side of the runway. Many of these events result in minor damage and minor or no injuries. Many are classified as incidents rather than accidents. But we must realize that even these seemingly insignificant events can have substantial financial and other repercussions for the pilot or the aircraft owner. An encounter with low-level wind shear can result in a loss of control, a runway excursion, landing short of the runway, or a collision with terrain or obstacles. We have four common producers of wind shear. They are frontal activity, thunderstorms, temperature inversions, and surface obstructions. Not all fronts have associated wind shear. In fact, shear is normally a problem only in those fronts with steep wind gradients. As with so many things associated with weather, there is no absolute rule, but a couple of clues tell you that wind shear may occur. The temperature difference across the front at the surface is 10 degrees Fahrenheit, 5 degrees Celsius, or more. The front is moving at a speed at least 30 knots, and you can get clues about the presence of wind shear during your weather briefing by checking these two factors. Wind shear is just one of the many unpleasant aspects of thunderstorms. The violence of these storms and their winds are well documented. The two worst problems outside actual storm penetration are wind shear related. These are the first gust. The rapid shift and increase in wind just before a thunderstorm hits is the first gust. And the downburst, which is the strong downdrafts from a dissipating thunderstorm cell as they spread horizontally as they approach the ground. The effects can easily be experienced 10 miles distant from the storm. This graphic from the Pilot's Handbook of Aeronautical Knowledge illustrates the possible consequences of encountering a microburst shortly after takeoff. We can see how the headwind quickly changes to a tailwind with an accompanying brief decrease in airspeed and a resulting descent. Next, we have wind shear being produced by temperature inversions. Pilots who have flown in the Southwest, Southern California, or Colorado are familiar with this weather pattern. Overnight cooling creates a temperature inversion a few hundred feet above the ground. When coupled with high winds from what is known as the low-level jet stream, this inversion can produce significant wind shear close to the ground. And finally, we have wind shear being created by surface obstructions. Wind shear from surface obstruction is generally associated with hangars or other buildings near the runway. The sudden change in wind velocity can seriously affect a landing. Some airfields are close to mountain ranges, and mountain passes are close to the final approach paths. Strong surface winds blowing through these passes can cause serious, localized wind shear during the approach. The real problem with such shear is that it is almost totally unpredictable in terms of magnitude or severity. A pilot can expect such shear whenever strong surface winds are present. So what is the reality of what can happen? Most commonly, wind shear-related accidents happen during the approach and landing phase of flight. Regardless of its origin, wind shear can change a routine approach into an emergency recovery in a matter of seconds. Here's a typical scenario of a pilot on final approach with a 10-knot margin above stall speed. Note that there is a 15-knot headwind. What if the headwind suddenly dies, as can happen in a wind shear situation? Momentarily, the airspeed will decrease by the amount of the previous headwind and will now be less than the airplane's stall speed. Even if the pilot can initiate a fast recovery, the airplane may land short of the runway. In this scenario, the pilot is landing with a 5-knot headwind, maintaining the 10-knot airspeed above the stall speed. But if wind shear causes a switch in the wind to produce a 15-knot tailwind, the airspeed will momentarily increase to 70 knots. The airplane will experience a momentary increase in pitch angle and a climb. The pilot will correctly respond by decreasing pitch, but will now be too high to safely land on the runway remaining. If the pilot does not execute a go-around, the airplane may run off the end of the runway after landing. What can we do to help prevent experiencing a wind shear-related accident or incident? Well, the best way is to avoid encountering a wind shear situation. First, it is essential to obtain a detailed weather briefing and pay special attention to the temperature difference across fronts and the speed at which the fronts are moving. We should also study terrain and obstacles along the route and on approach and departure paths. Compare the terrain to forecast winds to become aware of mountain waves or other obstructions to normal wind flow. Wind shear plays for keeps. Consider alternate routes or destinations or just delay the flight. And remember that if wind shear is reported, suspected, or conditions are ripe and you just have a bad feeling, you always have another option. Don't take off. Even if we do our best to avoid encountering wind shear, there still might be a time when we have an encounter. So here are a few of the warning signs that wind shear might be working its mischief. Timely recognition is essential. Be alert for any mismatch between expected power required and actual power required. Airspeed or ground speed variations in excess of 10 knots. Any unexpected vertical speed excursions, pitch excursions of 5 degrees or more, and unexpected heading variations of 10 degrees or more. The first step is to recognize and then brief the threat. Choose the most favorable runway considering wind, gradient, length, and obstacles. Do not rotate until the airplane is at or slightly above rotation speed. If wind shear is suspected while on the ground, within stopping distance available, of course, abort. If airborne, maintain best climb performance straight ahead unless obstacles necessitate a turn. Maintain a stabilized approach. Add at least half the gust factor to the approach speed. Monitor for deviations in speed, heading, or descent rate that signify wind shear. Consider using just partial flap extension to facilitate expedient climb out if necessary. Given the higher approach speed, monitor anticipated touchdown point and be ready to abort if it appears that you're going to be landing long. So in summary, we looked at some dangers associated with low-level wind shear, some common wind shear producers, examples of the effects of wind shear during takeoff and landing, and some strategies to avoid, recognize, and remediate wind shear effects. Thanks for watching, and thanks to Avemco Insurance for their sponsorship. For much more safety-related material, please check out our website, vectorsforsafety.com, and please remember to fly like your life depends on it. I'm Gene Benson.